In this video, I will discuss about AC/DC rectifier, a single phase, half wave, uncontrolled rectifier. Okay, in this video, we will use a load resistor and inductor load, and also we have freewheeling diode, FWD, or sometimes we call flyback diode. Okay, this is freewheeling diode. This diode we call freewheeling diode. This diode is not just normal diode. So we know that for uncontrolled rectifier, we use normal diode, just a diode. It's our rectifier. Okay, resistor and inductor, same as the previous video. We use resistor and inductor at the load, and we just connect this diode, the freewheeling diode, in between diode and load. To analyze our waveform, we divide it into a few parts. So first part is during positive cycle. Second part is during negative cycle. The first part is during positive cycle, which is from 0 to pi. Okay, 0 to pi. Okay, from 0 to pi, what happens is positive cycle here. So current will be plus minus like this. Okay, same. Say plus minus. So current will flow this direction from some positive terminal. So we can see that the diode, arrow diode like this, flow of current like this. So what happens there? Due to same arrow, so this diode will become forward bias or short circuit. Short circuit. So during positive cycle, diode short circuit. Okay, short circuit here. So then current will flow from there, and then current can go here, can go here. So current will split into two. Okay, go down and also go to the right. Go direction. The arrow of FWD is opposite. So opposite. Then when this, we know that for the opposite diode will become reverse bias. So open circuit here. Open circuit. So current cannot flow there. So there is no current. There is no current here. So all the current will go to the load. Okay, all the current will go to the load. Current cannot flow here due to current cannot flow through the FWD, through the freewheeling diode, due to reverse bias. So reverse bias, open circuit at okay, the open circuit here. Okay, current will go here and go to the resistor, go to the load, go to the inductor, and go back to our source. So we know that inductor will charging, and then inductor will charging during this time. Okay. So this one is short circuit, so 0 volt. So all the voltage, all the input voltage will go to the output due to diode is 0 volt, short circuit diode. So there is no voltage drop there. So all the input go to the output, means that the input cycle will be same, input waveform will be same as the output waveform will be same as the input waveform from 0 to pi. Okay, in terms of I naught, so current will follow the input. However, we know that we have inductor here. So this inductor will charging. The inductor will charging. Okay, that one is during positive cycle. Okay, for our diode, that is forward bias. So waveform of diode will be short circuit here due to forward bias. 0 volt forward bias. Our diode forward bias. So sorry. Okay, forward bias. So short circuit 0 volt. Okay, this one is the waveform of signal, a form of diode, a form of current, a form of output voltage, and a form of input voltage during positive cycle from 0 to pi. Okay, next is during negative cycle. Negative. Okay, let erase first. Erase all the nodes during positive cycle. During negative cycle, okay, this cycle we call negative cycle. Negative cycle from pi to pi. Yeah, negative cycle. From pi to pi. Okay. So negative cycle from pi to pi. Okay, previously during positive cycle, the the inductor will charging during positive cycle. Then we know that this inductor will store energy. Then during that one is during positive cycle. Then during negative cycle, so that's mean there's no current, no supply. So what happen is this inductor will become current source, and it will discharge the current. Discharge energy. So current will flow from here to here. This one is flow of current here from source there. Okay, look at this freewheeling diode. Okay, the arrow of freewheeling diode, same arrow with the current from our inductor. So same arrow means that this diode will become short circuit. Okay, FWD diode short circuit or 0 volt. Okay, when 0 volt, so current will flow from here and then go to the closed loop, go through the R. So the energy will be dissipated at R. Energy dissipated at R. Okay. So what happened is during this negative cycle, we know that this one is short circuit, 0 volt. So how about the voltage here? V out. Okay, this one and this one is parallel. So we know that for parallel circuit, the voltage is same. So probably this cylinder is short circuit 0 volt means that V out will be 0 volt also. Okay, due to parallel with the FWD freewheeling diode. So our output will be 0 volt. Okay, preliminary short circuit, so 0 volt. Okay, at this time, from pi to pi. Okay, okay, in terms of current, the current will be, okay, before that the current is fully charged, then the current will be reduced. However, uh, the decay of the current is not too much. This is just slow decay due to the dissipating power is just at resistor only. Before this, the dissipating power is go to R2 and also go to V source. In this circuit, we have short circuit here, so current will go here due to the short circuit. Short circuit means that there is less, very low resistance. That's why current will go through this area, through this link as terminal due to short circuit here. So all the current will go from this closed loop. So the dissipating power is resistance. The amount of is like say the decay is not too much. The decay is slow decay. Then until 2 pi. Then after 2 pi, it will same as this waveform. So they will follow positive cycle waveform. So it will charging again the current, and the output will be same as the input. Okay, in terms of this diode, our diode, okay, we know that this diode is reverse bias. So for reverse bias, this diode will be open circuit as open circuit due to reverse bias. Open circuit, that's mean so that's mean all the voltage, this voltage, diode voltage will be same as input voltage. So the waveform of input like this, change color. Okay, the input waveform of voltage like this. So all the input waveform will go here, V diode. Okay, same as V diode from pi to 2 pi. Okay, then during the positive cycle, it will same as previously. Okay. Okay, we can see that in this circuit, by using freewheeling diode, what happen is the current, we can produce continuous current. Okay, so current will continuously, we call continuous conductive mode. Okay, current will continuously. So okay, now okay, the what is conduction angle? Conduction angle is from 0 to pi. Extension angle is continuously, so that means all time. Our circuit will the current will flow all time, continuously. Okay, all right. So this our output will be V average equal to area divided by T period T. Okay, we'll get V average equal to 1 over 2 pi. So area is from 0 to pi Vm sine omega t d omega t. Okay, we get is Vm over pi. Okay, this is our V average. Okay, I think that's all. Okay, they ask for AC rectifier, AC-DC rectifier using single phase, half wave, uncontrolled rectifier, resistor, inductor. Our load is resistor and inductor, and also we use a freewheeling diode or flyback diode. Okay, thank you. See you. Bye bye.